In this video, we're going to be looking at key radians relationship with the various trig ratios. And you might be wondering, what are the things that you need to memorize back in the days when you were in high school, mainly in grade 11 and grade 12, where you're given the following angles and degrees. We actually converted this on our previous video to radians, and these are the values for the individual angles from degrees to radians. You should be able to check that out from our previous video if you can't actually figure that out, but if you did, that is awesome, because now we'll be using either these two, which could be interchangeable definitely in this video, into what are the results of the following angles. In this particular case, for cosine and for sine and for tan, you see the following values. You might be told to memorize this because it is important to do that in order for you to be effective in terms of problem solving. But what if I told you that if you forget, let's say for example, one of these particular 9 values for the specific angle that is given, how are you going to be able to do what? Figure it out. And in order for you to figure those out, we need to start off first with the following. When you are given the angle 30 degrees, and 30 degrees in this case is written in radians to be pi over 6, we are going to be looking at something which you should have remembered from your previous lessons, which involves the unit circle. And from the unit circle, in this case where our orange arm is positioned at this particular coordinate here, and this here is the measurement of your cos theta, and this is your measurement of your sine theta, which in this case is shown to be called 3 pi over 2, and in this case, for the other hand, 1 pi over 2, and you know that your unit ham is measured to be 1. For our angle, we need to determine what the value of our cos theta is and our sine theta. Now, in order for we to figure this out without giving this particular relationship, what we need to look at is extracting this particular triangle that is created here. And by extracting it, what we have now is the following. We see that yes, our opposite, which is the angle that is directly opposite of the side, is measured to be 1, and we are going to assign this particular hypotenuse to be 2. And what is the strategy that is required for we to determine the adjacent? The strategy to accomplish that is through the process called Pythagorean theorem, and by doing that we figure out that our adjacent is measured to be root 3, and therefore once we're able to figure this out and we are able to assign the following sides with respect to their numbers, we can now move on to the next step, which is to determine the x coordinate. And this x coordinate for our angle pi over 6 is of course adjacent of our hypotenuse, which is equal to root 3 over 2. And this is indeed the same as what we have here for our length measurement, x coordinate root 3 over 2, which is amazing to figure out. Now the next one here is how about our sine theta? You should be able to figure this out without me actually showing it to you, but voila, opposite of our hypotenuse, and this is equal to what? 1 over 2, which is 0.5, which is what we have right over here for our y coordinate, sine pi over 6. And on the other hand here, we are asked to determine what the tan theta is, and to figure this out, what we have to do is to opposite of our adjacent, and this is also equal to what? Sine theta over cos theta. And once you're able to remember these two relationships which are equal to each other, then you can do these particular numbers for our sine theta over cos theta from what we figured out here, and by so doing we can work our way to the equivalence of this other side. So therefore 1/2, which is for our sine of pi over 6, multiplied by 2 over root 3, which is what we have coming from our cos theta. This here is equal to 1 over root 3, or root 3 over 3. So this is amazing to see how you're able to figure out what your angle is in respect to the following trig ratios for angle pi over 6. Now the next one here is pi over 3. Pi over 3 pretty much similar to what we did for our 30 degrees, which is pi over 6. What we see now is that we know that our angle is increased by 2. So therefore, in this case, we are going to be going up. Root 3 over 2 decrease on our x coordinates, 1 over 2, and our arm it still remains to be 1. Therefore, if we translate this over to a right triangle that doesn't actually have too much of a fractions, put it that way, or for our specific sides, we can now address this to be root 3 as our opposite, this here to be 1 for our adjacent, by using Pythagorean theorem this is measured to be 2, and therefore our cosine is adjacent to hypotenuse, 1 over 2. Sine of pi over 3 is root 3 over 2, and finally our tan is sine divided by cos, which is also equal to opposite by adjacent. What we see is root 3 over 2 multiplied by 2 over 1 coming from our sine divided by our cos. This will be equal to root 3, and therefore that is how we're able to figure out what are ratios for angle 60 or pi over 3. Finally, here is looking at our 45 degree or angle pi over 4. And what we see here is that the sides must be equal. Our x coordinate has to be equal to our y coordinate. The reason is because we are halfway between 0 degrees and 90 degrees. Therefore, if that is the case, we can now determine what the measure of our x and y relative to our hypotenuse, which in this case is our unit arm length 1. This can also be translated to the triangle, which shows that, hey, if this side here is 1 as our opposite, this side here also must be 1. Therefore, for our adjacent and our opposite, we can determine what the hypotenuse is through Pythagorean theorem. We figure this out to be equal to root 2. Therefore, since this is root 2, we are now going to be able to determine our cos and our sine, which is the same for both, 1 over root 2, and for our tan, since sine divided by cos and they are equal, this means that our tan of pi over 4 is equal to 1. So in conclusion, our summary shows that in order for we to determine this particular block right here, which are the results of our trig ratios for 30 degrees, 45 degrees, 60 degrees, or their respective radians, we need to remember that we need to get our unit circle and extract the triangle. We see that for 30 degrees, we have our opposite to be 1, our adjacent to be root 3, and our hypotenuse to be 2. On the other part, which is for 45 degrees or pi over 4, our opposite is 1, equal to that of our adjacent, and our hypotenuse is root 2. And finally here for our 60 degrees or pi over 3, in this case for our right angle triangle, our opposite is root 3, which is flipped from our 30 degrees, which in this case the adjacent is root 3. So in here for our opposite, root 3, our adjacent is 1, and our hypotenuse remains 2. Remember that in all cases our hypotenuse are all longer than the respective opposite and adjacent. So once you're able to figure this out, you'll be able to determine all these numbers using what you know about your sine, cosine ratios and tan ratios. So that's about it for this particular video. There is a challenge that I'm going to share with you guys, and you can check this out. What will be or how you're going to be able to design a triangle for you to develop these following results for 90 degrees, 180 degrees, 270 degrees, and 360 degrees, and how is this going to impact the tan in terms of how is it undefined for 90 degrees and 270 degrees. All the same, I hope you found this really informative. Please hit a comment down below. Let me hear your thought about this particular video, and I hope to see you all on the next one. All the same, stay smart as always and believe in yourselves.